In this video, we're going to talk about inscribed angles, and before I formally define it, I want to talk about it in this picture over here on the right. So, in general, an inscribed angle is an angle that's formed by two chords with its vertex at some point on the circle. So if I take chord over here, chord AB, and I connect it with chord BC, and its vertex is at point B, which is somewhere along the circle, this by definition is considered an inscribed angle. Now this is different from a central angle. Remember, a central angle is formed by two radii, and the center or the vertex of that angle is sitting at the center of the circle. So this would be a central angle, and the one highlighted in yellow, this is your inscribed angle. So make sure that you don't confuse the two. So let me go back to the vocabulary box and define formally what an inscribed angle is for you to write down. So an inscribed angle is an angle formed by two chords with its vertex at some point on the circle. So my example would be angle ABC, which I highlighted in yellow in my picture because that is an angle that's formed by two chords with its vertex at some point on the circle. So now I want to talk about the inscribed angle theorem. The inscribed angle theorem states that when you have an inscribed angle, which is right here highlighted in blue, the measure of that inscribed angle is going to be half of the measure of its intercepted arc. So let me fill that in. The measure of an inscribed angle equals half the measure of its intercepted arc. So for example, over here, we have arc BC, and arc BC is measuring 80 degrees. So I'm going to write that right here. The measure of arc BC equals 80 degrees. So then what does that mean about the measure of my inscribed angle? Well, the inscribed angle is going to measure half of that. So I'm going to write the measurement of the inscribed angle, which is CAB, and that is going to equal half of 80 degrees. So the measurement of angle CAB will be 40 degrees. And the last thing I want to point out is that if an inscribed angle intercepts a semicircle, so here's my inscribed angle in green, and it's intercepting a semicircle, well, a semicircle measures 180 degrees, and if the intercepted arc is, the inscribed angle is going to be half of that, that means that the inscribed angle will always measure 90 degrees whenever the inscribed angle intercepts a semicircle. So filling in the statement, if an inscribed angle intercepts a semicircle, then the inscribed angle equals 90 degrees. And this happens for any inscribed angle that intercepts a semicircle. So it could be here and be 90 degrees, the inscribed angle could be here and be 90 degrees, and so on and so forth. So I'm going to do the first practice problem with you, and then you can finish the rest of this practice page on your own with your groups. So this first practice problem says that Angle 3 is an inscribed angle because its two sides are chords. So we just talked about what an inscribed angle is, and I'll highlight it here. This would be angle 3. We're naming it by its vertex. And then the second statement says that angle 1 is a central angle because its sides are radii. So angle 1 is going to be this angle. And then the last statement here says that both of these angles, angle 3 and angle 1, intercept the same arc. So this arc is across from both of these angles, or that arc is formed by both the inscribed angle, angle 3, and the central angle, angle 1. So if we're given that the measurement of angle CB is 60 degrees, then they want us to find the following measurements. So again, the measurement of arc CB is 60 degrees. Then we need to find the measurement of these angles. So if the measurement of the arc CB is 60 degrees, we know that the measurement of the central angle that intercepts it will be the same exact measurement. So that means that the measurement of angle 1 is going to also be 60 degrees. And then jumping down to the measurement of angle 3, well, we know that an inscribed angle measures half of the measure of the intercepted arc. So if the measurement of arc CB is 60 degrees, that means that the measurement of the inscribed angle for angle 3 is going to be half of that, which is 30 degrees. And then the last measurement they want us to find is the measurement of angle 2. And the way we can find the measurement of angle 2 is, well, if we know the measurement of angle 1 is 60 degrees, we know that the measurement of angle 2 is a supplement to that angle, meaning that when I add angle 1 and angle 2 together, I should get 180. So what I can do is I can take 180 degrees, subtract the 60 degrees, and I'm ending up with 120 degrees, which will give me the measurement of this angle, angle 2. Okay, so you can try examples 2, 3, and 4 with your groups, and I can walk around and answer questions. Thank you for listening.